Our next circuit component is possibly the most simple passive component there is, and that is a resistor. Resistors come in all shapes and sizes. This is one of the larger ones that you can use. It's got bendy legs and a big fat body. But they do come smaller than that. This is a standard size through hole. And they even come down in a size so small that they've got to be packed individually in little bits of plastic like this. So what's the purpose of a resistor? Well, a resistor is in a circuit in order to eat voltage, and equivalently you could say eat power. Let's imagine a circuit in which we have a 9-volt battery, and we also have an LED which only requires 3 volts. Somehow we have to get rid of 6 volts and regulate the current that's going to flow through that LED. So we might place a resistor in line with the LED. Its job is to take the 6 volts that's spare and convert it into heat. So a resistor converts electrical power, a voltage difference, into heat, and thereby reduces the current flowing through the circuit. These come in all different sizes, reflecting different amounts of power that they're meant to use. It doesn't necessarily reflect the resistance of them. For instance, this huge resistor is only 3.3 ohms. This tiny resistor is 330. So the amount of resistance isn't related to the size of the thing. For resistors like this, we have a convention that tells you how big they are, how much resistance they have. And that's these colored stripes that you can see on here. So this is our largest resistor, and you can see it has 4 color bands, 1, 2, 3, and 4. The first 3 color bands here tell you how many ohms of resistance this particular resistance has. You can look up a table which tells you how to interpret these different colors. The 4th band here, gold, indicates the precision of the resistor. That is, if you know how big it's meant to be, how likely is it to be close to that number in reality? For a resistor like this, which is quite cheap, although it says it's 3.3 ohms, it might actually be as big as 5 or as low as 2. The second resistor here is a little bit smaller. That means it can't absorb as much power happily, but you can still see that it's got these colored bands, 1, 2, 3, and the 4th for precision. This also has bendy legs. Here's the final resistor. This one is so small that I can't even hold it with my fingers properly. I have to use some tweezers. And on this one, you might just be able to see that instead of using colored bands, we actually use numbers to tell us how big the resistance is. This kind of resistor doesn't have legs, instead it's got pads. So instead of being placed on a circuit board through a hole, it's placed directly on top and then attached by heating up the contacts on either end. A resistor like this has a much, much lower ability to eat power than one of the larger 2 here. So if we want to draw a circuit diagram, regardless of how big our resistor is, physically, it has the same symbol in the circuit diagram. There's actually 2 variations of this. The first one looks like that. It looks like a jagged zigzag of wires. Typically, you would make it easy for somebody to understand by writing the value next to it. So you might put 10 ohms as the value of the resistor. An alternative is to use this simple rectangle. If you were going to use this symbol, then you might just write the value inside the rectangle. And that's all there is. Resistors are not polar. That means the current can flow either way through them. It can flow that way, and it can also flow that way. So it doesn't matter whether you draw a rectangle or this pattern upside down, it's the same thing.